So, approximate the area under the curve of the function on the interval using 6 subintervals and right endpoints. So if you have 6 subintervals and right endpoints, you have to take your A to your B and find your delta x. So your delta x is B minus A all over 6, which is 3 over 6, which is 1/2.
Now 39 is the answer.
In order to get the answer, you need to find the right endpoint values using the function and the right endpoints.
Oh my gosh, I have to do 1
So if it starts at -2 and we're using right, we ignore -2. And then we have to find, yep, -1.5, -1, -0.5, 0, 0.5, and 1.
Alright, nose goes.
Calculator.
Yeah,
Ow.
is that the calculator portion?
No.
Well, I mean, 3 halves, -3 squared is 9/4.
All right, f of 1, 1 squared is 1, 1 plus 2 is 3.
F of 0 is 2.
Yeah, and then -1 is going to be the same as,
1.
Negative one.
It's going to be 3.
And 0.5 and 5 are going to be the same.
exactly,
So
so
it's 2 and 1/4 for those.
you only have to find 0.5 and 1.5. So 0.5 squared is
2 and 1/4.
exactly
And
1/4, so
3
that's
halves squared is
2.25.
9/4 plus 8, 17/4.
Or you could just add it as a decimal, but sure.
I always convert it to fractions.
So she
Well,
tells
the
us
only-
to use it as fractions, and then she says decimals, and she hates decimal points, but make it make sense.
Can I use decimal points?
You can do either or.
4 1/4.
So 4.25. Okay, I got it, guys.
Did you get all those? Did you use your calculator?
No, just
She
use
used
yours.
her, she used her unit circle on.
Have you used that yet? You paid money for it.
I didn't pay money for it.
She got her dad to pay
It was
money
99 cents.
That's 99 more cents than I've spent on the unit circle.
Well, unit circle's coming back, so she's fine.
Yeah.
All right, add them
Yours
all.
is not fine.
All right, add them all up. So 4 plus 3 is 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.75.
Yeah, that's what I was going to say.
So now you have 1/2 times 16.75.
39.
Half of 16 is 39.
8.36.
So exactly, half of
25.
16 is 8, and half of 0.75.
It's 3.5.
No,
3.8.
it's 3.725.
That's what I said.
I guess I put it
It does uses the calculator. It's still off by like.
in my- Yeah,
A
I
lot.
remember that one time.
It's alright. Nothing.
So now she.
I did it just to mess with you. I did it just to mess with you.
That's a 3/16.
That's like a tape measure type thing.
Yeah, that's weird.
I actually need to learn that fraction decimal ratio because I don't know that.
All right,
And
let's
that's
do
a problem.
one more Riemann sum example. Do you want to go down to the table? Do you want to do 2 or 4?
4.
4.
2.
4.
Dude, this is
All right.
root.
Okay, and all you have to do is plug in 0 and -1 and 0.5 for all
It's all
that.
given for you.
2 is a calculator problem. You're not going to calculate the square root of 1 1/2.
Correct.
Oh, then we're fine.
Yes, 2 is calculator. So it's 3.
Yeah,
We
what
don't
in
even
the
know.
world?
That's just the
That's
integral
an
sign.
integral done.
Yeah, that's what we're going to learn next, like probably at some point this week. All right, number
It's called
4.
an ampersand.
No,
I thought
it is
was
not
side
called an
line.
ampersand. An ampersand
I
is
know, it's the,
Okay.
the and
Oh, so it
sign.
looks more like a sideline.
a rectangular canal 5 meters wide and 100 meters long has an uneven bottom. Depth measurements are taken every 20 meters along the length of the canal. Use these 4 depth measurements to construct a Riemann sum using right endpoints to estimate the volume of the water in the canal. So,
Alex, it's a rattlesnake.
Make it a king cobra.
Well, I can't, I already added the rattle.
the volume would be the width of each rectangle. So each rectangle has a width of,
20.
20.
good. So that's my delta x. That's what we're going to multiply all of the sums of the heights by. So the sums of the heights using right endpoints means we're going to use,
Everything except for 2.
exactly.
Yes.
So if you group those two together, it's nice because 0.9 and 0.1 make a 10.
Doesn't matter if you got another point one coming.
And a point
What's
6.
21 times, no, 20
It's,
times
if the answer's
9.5?
190. If I do my math right.
I don't think that's correct, does it, right?
9.5,
Times 20, it's 9.5 times 20.
which is what on the calculator?
190.
Thank you.
5, no, 190.
You put it into the calculator.
It's 190, I read it, it's
Mrs. Brad, what's the answer?
950.
Well, if you add those up and multiply them, it's 20.
You're not gonna get 950, I can tell
It's
you that.
9.5 times 20.
Whoa, what just happened? Oh, backwards.
1.6 plus 1.8 plus 2.1 plus 2.1 plus 1.9 is 9.5 times 20 is 190.
Alright, 4.2, 6, 7.6,
You have little faith. It's
9.5.
Oh,
But
times 20.
what did they ask
For
for?
the volumes, you have to multiply it by 5.
Okay, then you get 950.
yeah. I've been saying that this whole time.
Okay, so you
What is it, 190 or 195? Make up your mind.
190 times 5, 950. No, there's no 5.
So that 20 times the sum of the parts, and that 190 represents like the areas of the rectangles. But because we need the volume, you have to go and multiply it by 5.
Okay.
Meters cubed.
Yep.
Just in case anyone was wondering what those were.
I wasn't.
No one cares.
Well, if you were wondering why your answer was so wrong.
That had nothing to do with my units. And everything I should know.
Alright, we're done. I think I won that.
All right. Take out your notes. Let's go to the trapezoid rule.
Man, the first period isn't even over.
We are on it today. Maybe I
Because
found
Deja's
the
here.
problem.
Yeah.
No, the problem is Deja or Des because they're little chatterboxes.
With
Oh.
Oh.